Hello all and welcome back. So in this video, let us now move forward and now let's try to code the bubble sort algorithm based on our discussion. Now for many of you, this might be the very first algorithm which you are coding for sorting. So I want to explain you one thing, right? Please make sure that you are understanding the way I am trying to go to the problem rather than just chasing behind the solution. Okay. In this whole course, my aim is to make sure that you are comfortable with understanding that how we have to reach to a particular problem and not just basically make sure that we remember the solution or we have to remember this particular code. I have seen many students, they try to remember the code, and that is like the worst thing you can do, believe me, because it is not going to be helpful in a long run. If you are planning for tier 1 companies like Google, Amazon, Microsoft, interviewer is more interested in your approach than like seeing you how quickly you can code anything. Okay, great. So let us take an example, the same example, everyone. So we had this thing 12, 25, 11, 34, 90, and 22, right? Now, in the last class, we actually did a dry run on this of the first pass. So let me just go above and see. This is how we have done the overall dry run, right? So here you will notice that we are just comparing the adjacent elements and we are running 5 passes. Okay, that means if the length of my array is 6, then I need 5 passes. Right now, we will just think about a single pass, okay, and not all the passes. I know that a single pass doesn't sort my entire array. It just sorts it just take the largest element to the right position. But that is how you break the problem. Okay, great. So from this particular thing, we have these two things clear. So let us now try to code and just we will try to code what we are visualizing or understanding. Okay. So instead of just directly starting with code, we have to first see how the problem is getting broken in our understanding. Great. So let us take a function bubble sort. In this function, I will be getting an array. Okay. I have to make the changes in this particular array or list only, and I have to just return that. So unsorted list equals 12, 25, 11, 34, 90, and 22. Once this unsorted list I have, I will be getting a sorted list. Okay. And as I said, we can use in Python arrays and list interchangeably. That is all fine. You now are aware that list are the way we use arrays in Python. Normally, these are all the algorithms which are run on an array. Okay. So don't get confused in that. If you have not seen the previous video where I explained that, please make sure that you see that once. I will be just calling the bubble sort algorithm with my unsorted list. And I can just say now sorted elements sorted list. Great. So I am finally going to get my sorted list. That thing is for sure. Now let us see. Let me just zoom in a little bit more. Yeah. First thing is that I can get the n, which is the length of my list or array. Great. This is something which we have to get first. Now I know for the first pass, I have to do n minus 1 work, right? So let us see that in coding, everyone. For, let me write it j maybe. Okay, so for j in range 0 to n minus 1, this is what I have to do. Let me just zoom it out because else that will keep popping up. 0 to n minus 1. Now let us understand what exactly we have to compare. So pay attention here, everyone. This time, let us talk in terms of indexes. Okay, so this is 0, 1, 2, 3, 4, and 5. When I start, my j is equals to 0. Okay, so j is 0 when I start. And I compare it with the j plus 1 element, which is the first element. Great. Then my j will become 1. And this time I will compare 1 and 2. So what I believe we can use here is j plus 1. Okay, great. So it will become 1. It will become 2. Similarly, I move to 2, then 3. When I move to 3, 1 minute, yeah. So when I move to 3, then it's 4. And when I'm 4, this is 5. So this is the comparison when I'm on 4 and 5. Now let's say it is 5 and 6. But I think there is a problem. If we write or take j till n, so in this case, my n will be equal to 5, right? We are starting from 0. So the last index is 5. So you can take it as last index n minus 1 normally. When you write this thing, okay, so always remember this as well, very important. Whenever you write, let me write it in a different pen so you remember. Range 0 to length, okay, you get elements from 0 to length minus 1. You must have done those coding exercise which I've given you in the inbuilt data structure just to have your basics revised. After you must have studied for all the Python basics from Christopher videos. So it is again very important that you have these things clear. That was the major motive behind those coding exercises. So in a similar way, if I am running from 0 to length, okay, I will be getting till this thing from 0 to 5 because length is 6. But I see one thing, this last one I don't need. This last one I don't need because I don't have 6. Right, everyone? This is something which we saw above as well. We needed, in the first pass, we needed just 5 steps. Right? So, what does that mean, everyone? Let us now just try to code this out. Yeah. For j in range 0, n minus 1, this is why we are taking n minus 1 here. These boundaries are very important. Okay. Now, what are we comparing? If array of j is greater than array of j plus 1, all I'm saying is if this element, let's say in this case 25, is greater than the element next to it, j plus 1, then I will be swapping them. Okay. So a very good way we can swap in Python is something like this. So array of j and array of j plus 1 equals. Now I can just write them in an opposite order. So I can copy this here and I can copy this here. So what effectively this does, pay attention. It actually says that j will become j plus 1 array of j and this will become this. So it swap them internally. Okay, and that's a very good way. You can swap with a temporary variable as well. I think that you must have done in any of the coding exercise. But this is a smart way of doing overall swapping in Python. Great. So once you have done this, once you have now written all this full step, you can be sure that one element, okay, the largest element will be at the last. And we can check that as well. Return array. So let us run this. We know that it will not be sorted, but let's see what is the intermediate output. And I see the 90 getting to the last. Let us make it 120 and try to run to see if actually 120 is going to the last or not. And if I run this again, you see 120 going to the last. So what we saw in our visualization, in our understanding, step by step, we have just noted it down in our code. That is how coding should be. Okay, great. Now, since our array is not sorted, what we have to do? We have to again do the second pass. So this time I will be starting off again. So this whole step where I start with J0, let me draw it here. So 1 second, everyone. Yeah. So this was my pass 1, everyone. This was the pass 1. Now I will do the same thing for pass 2 as we saw, right? So we saw the same in the overall visualization on Hacker Earth as well. This time I will have j. I will have j plus 1. Everything will be same. I will start from 0. Okay, and I will compare them. Maybe we can write what we are getting after the first pass. So it is 12, 11, 25, 34, 22, and 90. This time again, I will start and just keep on doing the comparison. Okay. This is something which we saw in the last overall example, last in the video in Hacker Earth and as well as in our own dry run. We know that we have to do this thing n minus 1 times. Again, the reason we have to do this n minus 1 time is to make sure that n minus 1 elements are at the right position. Okay. For that, I will just show you one more thing as well. So pay attention, everyone. If, let's say, for passes in range 2. Let's say I just do it for 2 times. And now let us see what our output will be. We saw that in first pass, we were able to get the largest element to the end. That means in the second pass, I will get 2 large elements in the right position. And see, 90 and 120 is working fine. So I hope you're able to understand this, everyone. If I run this n minus 1 times now, okay, that would mean that my n minus 1 largest element will go to the right position. And I can show you that as well. N is 6. So let us see this one by one. 3. See, 1 second and range. I have to rerun it. Yeah. So it takes a second to save. That's why the output was same. 34. Now we see this thing. If I do it 4, then I'm getting it like this. Let me run it again. Yeah. I'm getting it like this. It is sorted in this case idly, but that should not be a problem. If I do 5, finally it will be sorted. Okay. So all I'm saying is I have to do this thing n minus 1 times. Now in the same way, n 0 to n, like I hope you know that this is 0 by default. So this will be running n minus 1 times. And now actually you will be getting your array sorted after you run it. So breaking the problem very smartly into smaller steps. Now you are able to get this. But programming is not just about getting the answer. It is to see, can you try to optimize anything more? Okay. Let us see what we learned in our last example. So last video, when I'm writing this 0, 1, then 1, 2, 2, 3, 3, 4, and finally I will write this 4 and 5. Now if you remember, we need to do this overall comparison in the last. We saw the same in the hacker earth as well, that this used to turn green, right? So if we go to the very starting and I move the element to the 90 to its right position, it used to turn green. And now let us see for the second pass. Are we doing this comparison? The understanding is, if something has reached to its right position, why do we need to compare it with anything now? So you will see that the last comparison actually will not happen. 34 will not get compared to 90. Okay. So pay attention everyone. See, 34 is here, 90 is here. This time we will not be comparing 34 to 90. Because I know 90 has reached the right position in the last pass. Because that is what my pass does, right? Each pass, that is what is happening. So for that, what I have to do, first one I have to run for all n minus 1 element. So I can write it as well, everyone, so that you remember. Pay attention. Again, this is very important. First pass implies n minus 1. Second pass, I can say that I just have to compare for n minus 2, right? So just n minus 2 element. In a similar way, third pass, I have to do for n minus 3. Now I just need something to subtract from here, okay? So that this thing happens. What can be that thing? I think this passes is a very good overall number for that. This pass will start from 0. So if I do minus passes, okay, it will be n minus 1 minus 0 initially. Then it will be n minus 1 minus 1, which specifically mean in the second pass I will get n minus 2. In the third pass, it will be n minus 1 minus 2, which will be n minus 3. This time we are starting from 0. Okay, so my passes are starting from 0. That's why in the second pass, I'm taking n minus 3. And in this way, I will be able to optimize it a lot, right? So let us run this now to see if we are getting it, the overall output nice. Great. Now, if you remember in the last overall video, I asked you to in the problem solving video, I asked you to check for multiple things, right? Let's say you're giving an empty array. I am getting the answer right. If you are given an array like this, will it work on this? This is a very good case where it is completely sorted in an opposite manner. If I run this now, I am able to see that it is running fine. Okay. So that's how you always check your solution. It should not just be check on the given test cases. Try to think of more test cases, the boundary and the edge cases, as they are the reason your code can fail. Okay. So great everyone. I hope you are able to understand each and every step that how we are going to write the code for any algorithm moving forward. Again, it is very important to understand and break down your knowledge, and then try to code it. So we first wrote this for a single pass, what we are doing, and then we used this passes to see how many pass we have to do. Okay, that's the way we will be coding in this whole course. So please make sure that when you try it out in the coding exercise, you are doing justice and giving enough time. That is a lot required. Okay, great everyone. So I hope this is clear. Now, if you have done this already in the coding exercise, pretty good. If not, just try to now code it again based on this understanding. And I'm pretty sure you will be able to code the same from scratch.